Today we'll be using what we learned yesterday about areas of squares to help us find side lengths of tilted squares. This is going to be entry 55 in your notebook, so please make sure that you've set up the inputs accordingly and outputs accordingly on the right side. For our warm-up today, you are going to try and find the area of the tilted square on this coordinate plane. After that, you are going to use that circle to help you estimate the side length of that tilted square. Take 5 minutes to pause this video and try this warm-up. Go ahead and check your answers for the area of the tilted square. The area of the outer square is 49, and the area of the right triangles add up to 20, so 49 minus 20 gives you the area of the tilted square, which is 29. To estimate the side length of the tilted square, we can use the circle to help us, because the side length of the square is the same length as the radius of the circle. That means wherever the circle's outer edge touches has the same length as the side length of the square. So the circle extends all the way around to intersect at this point here on the y-axis and this point here on the x-axis, both of which have clearly defined numbers like a number line, so we can estimate which numbers this length lies between. If we look and count here on the x-axis, then the length extends all the way to this spot right between 5 and 6. So we could estimate that the side length of our tilted square is between 5 to 6. It's almost at the halfway point and a little bit under that, so we could estimate about 5.4 as a side length. But what if we don't have a circle conveniently drawn on a coordinate plane for us? In that case, we can estimate the side lengths of a tilted square by using our knowledge of exponents. First, we would need to find the area of the tilted square, which again involves drawing that outer square with the easier area to find and subtracting those right triangles bordering the tilted square from that, and that will give us our area of the inner tilted square. So next we want to find the numbers that can multiply by themselves. In other words, numbers that when you raise them to the second power, meaning number times that number again, will give you a product after you multiply them that is close to that area of that tilted square. So in our example here, we're looking for what side length S can give us an area of 73 when they are multiplied by themselves. What S times S would give us 73? We can test out numbers if we're not sure. For example, 3 times 3, that doesn't get us anywhere close. If we try bigger numbers like 8 times 8, that does end up getting us closer. 8 times 8 is 64, and that's pretty close to 73. So I'm going to write that as a potential answer. 8 times 8 is 64, fairly close to 73. The next larger number would be 9 times 9, which is 81, and that's just slightly larger than 73. So I'm also going to put that as a possible side length. 9 times 9, 81. Because neither of these side lengths, either 8 or 9, gets us exactly 73, we'll have to assume that the number that we want, the side length that we want, is between 8 and 9. It may help to picture these areas as being on a number line. So an area of 64, an area of 73, an area of 81, and then the side lengths that could multiply to make those areas. To make 64, you'd have to have the side lengths 8 times 8. To make the area 81, you'd have to have side lengths 9 times 9. So that would mean in order to get 73, an area between 64 and 81, you'd have to have a number that's between 8 and 9 in size. What if we want to find the exact side lengths of a tilted square? Mathematicians have even invented a symbol that shows exactly the side length of a square. This symbol for the inverse operation of squaring a number is called a radical or a square root. And it looks pretty much like a division symbol with a little tail in the front of it. So let's say our area was 73. Our area from earlier of that square was 73, and the side lengths need to be multiplied by themselves to get us that area of 73. So to figure out that side length from this formula, s squared equals 73, all we have to do is do that inverse operation of square rooting, which means s squared equals 73. We just square root both sides of it. We draw that square root symbol on both sides. That square root symbol cancels out the square on the s, so we're only left with 73 inside of that square root, and that's our final answer. The exact length of that tilted square would be square root of 73.